So Hwk14 question 7. I'm going to start with A because this is a bit of an essay when it comes to maths. All we got then is a water barrel, and in the question it's mentioned about volume, it's mentioned about the external surface area, and we want to show that the total external surface area, S centimetres squared, of the barrel is given by S equals pi r squared plus 120,000 over r. Okay, so what we need to do really is work out how we're going to obtain this. Now, if you think about how you get surface area of a cylinder, well, it's just like two circles and then the circumference of a circle. So we know the circumference of a circle is pi times diameter. Yep. Okay, so Hwk14, and this is question 7, and we've been asked to show the external surface area of a barrel. And this is given, as I've written here, by S equals pi r squared plus 120,000 over r. Now, in the question, you've got to look at what they kind of what they're given to you, what information they're kind of given to you. So they're clearly after surface area. So you think of a surface area of a cylinder, that'd be like two circles on either side, and of course we want the diameter. Now we know diameter of a circle is pi times diameter. The circumference of a circle is pi times diameter. However, also we don't want anything to do with diameter in this case, so we're going to have pi times 2r. If I put 2r pi like that. Okay, so that's the curved surface of the barrel. Now, we've got to be really careful here because you've got to look at the question. They're saying that the barrel has a base but no lid. So, in normal circumstances, we'll look after the surface area of a cylinder would be working out the top and the bottom. However, in this case, it hasn't got a lid, so we're only after one of the circles. And of course, we know then a circle is just pi r squared, like that. And of course, sorry, just back to this, 2 pi r, and then of course we're times it by h, because also we've got all the loops as you go along the cylinder. So the curved surface area of the cylinder is 2 r pi h, and then of course our circle, our base is just pi r squared. Now, what I've noticed as well is they've referred to volume in this question, and they're saying that the barrel is designed to hold 60,000 centimetre cubed of water when full. And of course we know the volume of a cylinder is just pi r squared h. And of course we know then, of course, that pi r squared h is just 60,000. Okay, now this is what I tell my students to do really. We have got the surface area equation, that we know that's the surface area equation. We look at it in the practical terms. That's the surface area equation of the barrel. However, they want us to prove it's that. So what I usually say is, you know, what's gone missing? What's gone missing from here to here? And you can see the letter H is gone. So what I suggest is we rearrange this equation here to get H. And of course then we know that H equals 60,000 over pi r squared, like that. Okay, so we got this, and of course we got h in there. So we want to do some substitution. So what we're going to say is S equals 2 pi r, and then we're going to have 60,000 over pi r squared plus pi r squared, like that. Of course, we're going to have a few things that cancel out here, because we've got 2 pi r, got 60,000, then we've got pi r squared. We know 2 times 60 will give us that 120,001. Of course, we're going to have, if I do it in 2 stages actually, just so you can see what's going on, we've got 120,000 pi r, and of course that'll be all over pi r squared. And of course we know that pi r there is going to cancel out, and we're going to be left with r on the bottom, and then of course we're left with here 120,000 over r plus pi r squared, and that's exactly what we wanted. Okay, so part B, this usually follows the same pattern. You know, you have to show, part A is usually showing that equation is given by formula, part B is usually finding like a minimum or maximum value. Now after the minimum value of s, and we know that s is pi r squared plus 120,000 over r. And of course, in order to find the minimum value, we're going to have to differentiate that. So what I recommend before differentiating is just getting everything into a nice function that's quite easy to work with. So we'll put it like that. We'll put 120,000 r to the minus 1. So what we're going to do now is differentiate s with respect to r. And we're going to get 2 pi r minus 120,000 r to the minus 2. And then of course we could rewrite that as 2 pi r minus 120,000 over r squared. Now we wanna obtain a minimum, so if we set ds over dr equal to 0, we know that 2 pi r minus 120,000 r squared is equal to 0. So what we're going to do then is going to multiply everything by r squared, because then it gets rid of the divisor there. So we're going to have 2 pi r cubed minus 120,000 equals 0, and then of course do some more rearranging. You're going to get 2 pi r cubed equals 120,000. Of course divide both sides by 2. Get pi r cubed equals 60,000. And then of course if we divide both sides by pi, we have r cubed equals 60,000 over pi. Now obviously this is not a very nice thing, so what we need to do there is r equals the cube root of 60,000 over pi. Obviously this way you're going to need your calculator. So 60,000 divided by pi is 90,098.6 to 1 decimal place. Then of course if we cube root that, we're going to have r equals 26.73. Now because they're after the minimum value of s, we also want to plug in our value of r into the equation. So in this case s will equal pi times 26.73 squared plus 120,000 over 26.73. And of course put that all into a calculator. and we should get 6,733.9, but of course because we want 3 significant figures we're going to use 6,730, and of course that'll be centimetres squared, sorry. Okay, so part C, we need to verify that the answer that we attained for part B is a minimum. So in order to do this in differentiation, we need the second derivative. Now we got our first derivative from part B, which was ds over dr, which was 2 pi r minus 120,000 r to minus 2. So we differentiate this again. We can have 2 pi plus 240,000 r to the minus 3, like that. Now, if we want to rewrite that a bit more better, we can write like that. Now, the only time that this will become a minimum is if this is going to be greater than 0 once we plug in our value. Now, we know r is 26.73, so we're going to plug this in. So we're going to use r is 26.73, and of course when this is the case, d squared over ds, d squared s over dr squared will be 2 pi r, God I can't talk today, 2 pi, sorry, plus 240,000 over 26.73, all cubed. And of course, so we get that into the calculator. Okay, good. And of course that will mean that d squared s over dr squared is 18.85, and because this is greater than 0, this means that this is a minimum value.